Thank you for coming in large numbers. I'll be giving a brief introduction, and then I'm answering your questions as good as I know. It would be great if you could collectively extend the pad with the answers we're discussing. Maybe we can turn some of that into wiki.debian.org guidelines after that. So what is a cross-build? In Debian we have, and especially in dpackage, we have particular terms related to that. And the most important ones are the build architecture, the host architecture, and the target architecture. And the thing to remember is build is the box you are building on. And host is the thing you are building for, where the build product will run. And target is the thing you never need unless you know what you're doing. Unfortunately, some upstreams use different terminology, and they say host to what we term as build, and they say target to what we use as host, and they have nothing for target. So that may be confusing at times. So most of the time it's build and host that you need. And when build equals host, it means you build it on that box and run it on that box. It's a native build, and it's what you usually do, right? And if they differ, we call it a cross-build. So that's rather simple thus far. How to set up a cross-build environment? Well, if you have a native build environment, you already do have a cross-build environment, most likely. It's a simple matter of passing the right flag, at least for sbuild and for pbuilder. That's readily available. If you need it for other build environments, well, we can consider adding it there. But those are the most common ones. We also have a service called crossqa.debian.net, which regularly builds random packages. And you can just append your source package, favorite source package name over there, and see how it's going. Recently, Johannes implemented Salsa CI. So you can have your packages on Salsa automatically tested for cross-building. It seems some people already do that. And if you have cross-building questions beyond DebConf, please do contact debiancross@lists.debian.org or stop by the Bootstrap channel. In case it becomes very popular, we may consider splitting it, but, well, cross-building originated from that channel, kinda, so we do it over there. That's for my basic introduction, and now I'm looking into your questions. I can start with the one that was already on the pad, or you can do some. Is the one asking for Ruby stuff here? Someone asked, why does my Ruby stuff not work? And the answer is difficult. This is a multi-arch thingy. So if you have a Ruby package and you want to cross-build it, first of all, no, it does not work today. I need to sit down with Lucas and fix that, and it'll likely not work this year. So what's happening here is it tries to install gem2deb. We already turned that package architecture any, but some of its dependencies are not installable, as you can see there, and those typically involve architecture all packages. The important thing to understand here is that any time you have an architecture all package, it's architecture independent, it is treated by dpackage as a native architecture package. And native architecture is quite simply defined as the architecture of the dpackage package. Yeah? So that's what your system architecture basically is. So if you want to build for ARM and you depend on an architecture all package, well, it's only available for, if your build architecture is AMD64, AMD64. So the dependency is unsatisfiable. So architecture all packages are not that helpful in cross-building. The way to fix that often involves adding multi-arch foreign. This flag says, don't care about the architecture of this package. Unfortunately, while it's easy to add, it's not always correct. Sometimes it's the wrong thing to do, because even architecture-independent packages may expose interfaces from underlying packages in an architecture-dependent way, and that makes them themselves architecture-dependent in a behavior. So please don't blindly add multi-arch foreign to architecture all packages. Sometimes it's right, sometimes it's not. It's difficult to figure out. The question to ask is there a reasonable way to figure out whether the package runs on one architecture or another? So if you're dealing with textual formats, the answer is probably no. And if the package is something with binary formats, it's really architecture dependent. And well, oftentimes it's not obvious. You are encouraged to do an analysis, write it down and send it to Debian cross, and someone will probably check it. So in this case, yeah, your package doesn't cross-build. One of the first things to fix is bundler, because it is such an architecture all package, and it cannot satisfy the dependency.
You said the text is probably okay, but I could imagine that UTF-8 is endianness dependent?
UTF-8 normally is not. I'm not sure whether there is an endianness dependent variant of that, but normally it's okay. Further questions? I could check whether there are more below. So which language ecosystems do work? That's difficult. It's work in progress. I can tell you about the current state. So C and C++ basically work. It's needed for architecture bootstrapping, and it works best, kind of. For Go, we are kind of working on it. There are some rough edges to sort out, and package building does not work. But actually using Go to cross-build on Debian outside of a packaging context works somewhat. For Ruby, it's difficult. There is more than the issue we've faced over there. Especially, well, if you build Ruby extensions, we need the Ruby libraries there, and Ruby has some config module describing its layout, and it isn't in the right place, kind of. I'm not sure whether it's useful to expand on that, because Ruby doesn't work at the moment. Python does work in principle. Perl does work in principle, much thanks to Grigor, who did a lot of work there. For Perl, it would be awesome to have all Perl extension modules depend on a package that's called perl-xs-def, which says this is a Perl extension module, and it's a virtual package that pulls in the right stuff, and then it magically starts working. So every time you're building a Perl extension module, pull in that build dependency, and you have a good chance of making it work. It's not a promise. If your package uses package config or other weird stuff, it can still break, because Perl doesn't forward the right package config runes. Speaking of package config, it's in most other ecosystems, it's kind of guaranteeing that it will just work. So what other languages? Haskell. Haskell is we have made some effort at cross-building Haskell itself. I have no idea about cross-building Haskell packages, libraries. No, I haven't tried it. No clue. It probably doesn't work due to dependencies. Rust. The Rust maintainer is awesome. He's made it just work, for the most part. I haven't done basically anything about Rust cross-building, but it seems to work quite well. And I'd forward questions about cross-building Rust stuff to the Rust maintainers, because they're doing awesome work there. Any question, any language I've missed? Please raise your language now.
Free Pascal.
Okay, no clue.
What's the issue with Python? Can you take a microphone, please?
Python. So with Python, the situation mostly works, especially if you use the automatic stuff from DebHelper and DHPython. The build dependencies will look a little funny. I'll try to write them down somewhere. Python, you basically need lib Python x.y dash something all or nothing dash def and Python x.y something any, or probably native is better. I don't care. It doesn't make any difference in build depends. So it's a bit unfortunate that we couldn't manage to fix that in a better way thus far, but you really need both when building extensions. So this something can be all, or it can be dropped, and the version can be there or dropped, and well, depending on your particular application. Yeah, sometimes it contains debug, and sometimes not. That's the idea of how to do dependencies there. Any other language ecosystem? Can someone help take notes, because I can't like type and talk. Oh, you do, or do you? What? Does changing architecture all to architecture any help? Yeah,
One question about the Free Pascal. I've never looked into it, but Free Pascal tries to support cross-building natively. Have you ever looked at that, or is it just like that area?
I do think I looked at Pascal at some time, and I vaguely remember that Pascal enables it using flags to the compiler, which is kind of different from most other ecosystems. So in order to get Pascal work, we kind of need to mandate that packages pass the right architecture to the Pascal compiler, which is not happening today. And we probably need to relay out the packaging, because it only does some architecture combinations on the Pascal compiler. So the packaging needs to expose which architectures as host architectures are supported by the particular compiler binary package. If you're interested in that, we can sit down at some time. It'll be more than an hour. Okay. So, shall we proceed to the architecture always, architecture any? Yeah, so the question needs a bit more exploration. So we already had the issue that architecture all does not always satisfy the dependency. And I said, well, you can sometimes mark it multi-arch foreign. Well, then it will work. And when you can't, I didn't say what to do. And yeah, when you can't, the most likely solution is to turn it architecture any, oftentimes combined with multi-arch same, which kinda is an abuse, because the package contents are still architecture independent, and they will be equal on all architectures. But the difference here is that in turning it architecture any, it is able to forward architecture constraints that are inbound to the package to its own dependencies. So this typically happens in ecosystems which are interpreted, which makes it coins its name as the multi-arch interpreter problem, where you have some module which is architecture independent, like source code for Perl, Python, Ruby, and like that, which is being used, but itself depends on an extension, which is written in C or like that, and loaded as a shared object module. So if you depend on the module, and it depends on the extension, you want the extension architecture to match your own architecture. Otherwise, you can't combine it into a single process. And if the module is architecture all, it has no way of forwarding the architecture constraint to its own dependency. And this is called the multi-arch interpreter problem. And, well, we've spent quite some hours on coming up with a fix, and it didn't work out. So all I can offer is the multi-arch interpreter workaround, which is turning it architecture any. When in doubt, please do consider asking Debian cross@debian.org. Okay, what about the object introspection? Well, yeah, difficult. Why are you only asking difficult questions? Okay, can we have some easy ones? So, object introspection is about integrating shared libraries into interpreted stuff. And it's kind of part of a foreign function interface. And the introspection part derives information from the shared library. So at build time, when it builds the shared library, it loads the library into some process and extracts information about it. Now, loading it into a process works only if that process matches the architecture of the library, which in a cross-build typically is one we cannot run. So no, this will not work. So any package that uses G-object introspection will not be cross-buildable. It has some more problems beyond. I've looked into how other distributions do it. There's PTXDis, there is Yocto, and some others. And they basically all do the same thing. They use QEMU, which kind of defeats the purpose of cross-building. We may eventually end up doing that, but, well, I'm not too keen on, well, adding QEMU as a build dependency on G-object introspection stuff. So generally, the idea is if you see G-object introspection, consider using a build profile, no GIR or like that, and then cross-building it without G-object bindings, if it's important to you. So yeah, I think we've reached the bottom of the questions over there. And now we can go more interactive.
I suspect that a lot of the build profiles on the build profile spec wiki page derive from cross-building. You have any
partially
one on there that you might want to elaborate on?
They originate more from bootstrapping. Because in bootstrapping, you need to solve dependency cycles, and profiles are prime mechanism for breaking dependency cycles. Although, admittedly, there are two build profiles that are quite important to cross-building. One profile is no check, because during cross-building, we can't run the host architecture stuff, so unit test suites typically do that, and it'll fail. So what we did is, whenever you ask sbuilder or pbuilder to do cross-build, they'll automatically sneak in the no-check debbuild option and the no-check debbuild profile and disable tests for you. You can enable them again if you want to run QEMU-based tests, or if you're doing a sibling architecture where you can actually execute it. And the other thing we do is we sneak in a profile called cross, which allows you to add additional dependencies that are particularly required for a cross-build. So in some cases, it's useful to, what happens is that you build some tool and you install it, but you also use it during build, and the tool happens to be architecture independent. And in order to avoid building it twice, you can build depend on your own package and pull the installation copy of the tool to do the transformation while installing the binary you just built into the package. But that is a dependency on yourself and makes bootstrapping in the archive hard. So the idea there is you annotate that dependency with a cross profile in a positive way, and since the build profile is disabled by default, the buildies will ignore the dependency, and it'll only be available during cross builds. Am I doing things too fast, or can you follow? Good. More questions?
So you wanted an easy one. How does the toolchain figure out when installing build dependencies, when to install host architecture stuff and when to install build architecture stuff?
Quite simple. Install host architecture stuff.
Okay, so you have to
so
do that
all the
manually
build depends are interpreted as host architecture dependencies. When you see a build dependency, it's host architecture. Of course, that's not always kind of true. If the package happens to be multi-arch foreign, then the architecture doesn't matter, so it will prefer the build architecture. So that's on this providing side. And if you happen to know that you really need the build architecture library, you add :native. And then you pick the build architecture one. So it defaults to doing host architecture resolution. More questions?
So, might be a bit fundamental. You discussed a lot of issues when cross-building. So, in a way, is it worth the efforts? Why are you are doing all this work and you encountered lots of problems? So, and might be a question: how many packages cannot be cross-built because? So, is it worth doing all this?
That's a tough question. I'm not sure.
I can't say it just because I can.
Well, there are many advantages to doing it. One is it's required for bootstrapping. But that only covers a smaller set of maybe 300 source packages. So we really need to be able to cross-build those packages. Otherwise, we cannot do architecture bootstrap. Then cross-building arbitrary packages may make life simpler when you just need a package for a particular architecture. And you're lazy and don't want to build it on a portal box. It's faster, it's convenient maybe after having done the work, not before. Then cross-building random packages has the benefit of uncovering tooling issues. So I mostly do it for figuring out what fundamental tooling do I need to fix to make it work for more packages. That's basically my motivation.
Do you envision this being useful for slow architectures, or maybe even in Debian in the archive where we build everything cross for a certain architecture?
Yeah, that's something we can discuss once more packages do cross-build and we have a better idea of which packages actually are cross-buildable. So I was vaguely proposing the idea that we could maybe eventually use for some slower 32-bit architectures cross-build nodes for packages where we know that it kind of works well. And if it cross-builds, we run auto-PKG tests, and if they succeed, we could accept that as a result that is good enough, similar enough to a native build, and repurpose the build as auto-PKG test nodes. I think that's something that can be discussed. It would, in particular, fix the issue around the address space limit. Yeah. There's a form in between that. It's also theoretically possible, not today, to have a 32-bit change root and install a cross-compiler targeting the change root architecture, but actually being a 64-bit binary using multi-arch. So that would be more like a native build, but you're sneaking in a 64-bit address space compiler that actually targets the architecture of your change root. And that's also possible in principle. You cannot do it right now. There's this GCC for host thing that we need to fix up first.
How far are we? You?
I've got a patch, and it would be awesome if we had some more reviewers and testers for it. It's kind of stuck.
I meant in percentage, what do you think? 10, 50, 80% cross-buildable? Or
How many
less?
packages are cross-buildable? Yeah. I think we're pretty close to 50%.
Impressive.
Yeah, and the ratio of the largest chunk of not being cross-buildable is not cross-satisfiable. Okay, more questions.
Hey, so someone told me that the number of packages that are cross-buildable has been like on a plateau for
Yes.
some times, and that the rate of new bugs related to cross-building and closing bugs more or less
Yes.
balances. Why are there so many new failures to cross-build? Or I would have imagined that the number of packages that succeed in cross-building would monotonically increase.
Yeah, one would hope that would be the case. So for instance, when we transition from Qt5 to Qt6, we basically start with a new ecosystem and it isn't cross-build ready and basically everything fails. Yeah, and like that. So larger transitions tend to break cross-building. Is that sufficient answer?
Yes, thank you.
More questions?
Imagine a package which doesn't build fully without. Okay, let's.
Can you speak a bit
again.
louder?
There are no loudspeakers here.
Okay.
Okay, so imagine a package which builds.
It works.
Which
Okay.
builds its own documentation.
Yes.
So if you, but it doesn't have to, so it can omit it in a cross-build environment. It just leaves out its documentation, so it builds halfway.
So when you build documentation, you have first of all a choice whether to include the documentation in the package itself or whether you add a separate documentation package. If you add a separate documentation package, that will typically be architecture independent, and then you'll be very happy because you don't get to care about it during cross-builds. And that's not the case you're looking at, right?
Documentation generator, which generates its own documentation.
I suppose that's the case for recursive self-dependency.
Kind of, yes.
Yeah. So in that case, I would look into the options. Either you build it multiple times, which is something we do for PAM, I think. When you cross-build it, it's built twice. A few other packages do that. Or you can look into using a cross-build profile and depend on the documentation generator itself, running it, the system copy of it during build.
Yes.
There is no straightforward, that's the way to go. It really depends on your case.
Okay.
Look what is most convenient to you.
My question is this repeated build stuff which you mentioned, that building the package twice, building it first,
Yes.
so that you can build it again and generate it fully. So the first build of the package won't be complete. It will miss documentation.
So you include the documentation in the binary?
Yes, in a simple case. Yes, I'm building about. I'm talking about staged building. When you have to build twice.
Okay.
First to to build the documentation generator.
Okay.
You mean, and then, but on the first stage, you can't generate the documentation itself.
Yes.
Because you can't run the binary.
So when you need to do the documentation generator thingy, I think you first build it for the build architecture, where you don't need a stage. You just build the whole package, and you can run the documentation generator during build. And then you use the build architecture build to cross-build the host architecture package, right?
I didn't follow exactly.
I think you're concerned with the documentation generator requiring itself somehow.
Yes, generating its own documentation.
Yeah, so if you want to run the documentation generator during build and you have a self-dependency, then that self-dependency is better using the build architecture one, right? Because you want to run it. And for the build architecture one, you don't have a problem because you can run it already. So you first perform a native build, where you build a documentation generator and run it, and everything is fine. And after performing the native build, you can perform the cross build using the previous native build.
Yes, and do I implement it in Debian rules?
Yes. So if you're going that route, then your Debian rules will basically go like, if the cross profile is there, I'll then point my build system at using the documentation generator from the system, and if the cross profile isn't there, use the one I just built.
So there is no support to Deb helper or whatever, or...
Now, it's really a special requirement, and that's part of what the maintainer is supposed to do. Yeah.
Okay,
Or
thank you.
some porter is supposed to deliver as a patch for the maintainer.
Was wondering, maybe it's helpful to explain the difference between cross-building and bootstrapping or rebootstrapping, and where they help each other and where they're really different. I think I see a lot of shared problems. And
Yeah, well, so bootstrapping comes in two flavors: native bootstrap and cross bootstrap, right? And those are completely different. So the native bootstrap problem is about, you have this box and you want to use as few binaries as possible to build everything. And that's what the GNU Mess people do. It's what GUIX does. It's what Daniel Schepler is doing a lot. And it's what I did not do at all. It's a really hard problem because you really want to have a very small binary seed and then build everything from that natively without any cross-compilation. You have a single CPU architecture, you have very few binaries and order it in the right way, break cycles and like that. And then there's cross-bootstrap, and cross-bootstrap essentially is you have all the sources available and you have all the binaries available for one architecture and no binaries available for another architecture, and then you want to pull the binaries for the other architecture out of thin air from what you already have. So making the jump from one architecture to the next, that's cross-bootstrap. And yeah, it involves cross-building, kind of, yeah.
so I guess then there where cross-building helps is to bootstrap in the cross flavor of that.
Yeah, well, yeah, cross-building is the essence of cross-bootstrap.
Packages instead of only the pieces that you need
Yeah,
to bootstrap
doing it for all the packages has the slight advantage that every now and then some package joins the build essential build closure. And it's way easier to support bootstrapping if that package happens to already be cross-buildable. Otherwise, we'd be having unstable, not be cross-bootstrappable for quite long, because I'd figure out, oh, this package was added to the bootstrap set. Now I need to figure out how to make it cross-buildable, and when I'm done, some other package is added. It actually happens more often than not.
But I guess your focus then is mostly on the low-level tools, or do you prioritize in your efforts?
When I do cross build QA, I basically use popcorn, but if you have a better measure, just so.
Well, we have measures. There's plenty, I guess.
Yeah. You can also tell me which packages you port to you. Look into that maybe.
I'm not a porter.
Well, in a way, I was surprised to get these fails to cross-build for some leaf packages with popcorn count of 10 or so.
No, I don't think I do popcorn 10.
Well, but little. Well, I hope I wasn't too sharp a few minutes ago. It's just I appreciate your efforts, the aspect of uncovering flaky build systems or build structures, and well, this certainly helps. Thank you for that.
Yeah, I figured that even in my day job, I would occasionally see like, okay, this package almost works, but it has a bug. I need to patch it, and then I need to build it for the embedded board. Oh no, and now I need to cross-build it. And I'm happy when it already works. I can fix it, upload it, and be done. It just makes for a more convenient experience. And yeah, that did work out for me quite a number of times.
So I was about to ask about do's and don'ts for Debian packaging, but I figured you already have a huge wiki page on that. So this is the cross-building packaging guidelines.
Yeah, I think we're
it's even
supposed to
mentioned there,
improve
yeah.
that page to make it easier.
So
I wasn't expecting that kind of interest in cross-building.
be glad. Be glad about it.
So if more people fix it, yeah, we should improve documentation. And as more questions get asked on the list, we'll probably be adding the answers to the cross-build packaging guidelines.
Has there been any progress on LLVM, using that as a build dependency?
I think the LLVM people are being unhelpful in some way because well, it's actually upstream. The problem there is that we have this LLVM config thingy, and it is fundamentally incompatible with cross-building. You cannot make it work. So we asked them to provide the package config file, and they basically said, no. Well, that's where it stands. And then that means don't use the VM for cross-building because it doesn't work.
Okay, the answer I got when I asked last was, we are out of time, please help. And then I was out of time and nothing happened. Okay.
So upstream is being unhelpful there because they refuse to use package config for reasons beyond my understanding. It's extensible, and even Postgres manages to do that besides pgconfig. So should be doable, but upstream refuses to do it, and when upstream refuses, downstreams refuse to use it because it only would work on Debian. So that's something that needs to be fixed upstream.
You mean building LLVM itself or using it?
Using it.
Using it. Yeah, there was something about spraying multi-arc annotations everywhere and making sure that's the right thing.
LLVM has the multi-arch annotations wrong, if I remember correctly.
Yeah, right. That needs fixing, I guess. That's
one
of the steps.
I tried a number of times. It doesn't work.
Yeah, and then it builds a long time and it takes, whatever.
No, I tried cleaning up the mess, but communication somehow didn't work, and then I gave up. If you happen to know a LLVM maintainer over here or like that, let's sit on a table and fix that.
Do you have any success stories, in particular packages that you can cross-build that we can't build on the buildies that you can think of?
Ooh. What do you mean can't build on buildies? Like address space limits? I'm not aware, no. Well, most of them are invoking C++ compiler, and C++ compiler is one of the things that tends to work good with cross-building. So those tend to blow up the buildies. It should work. So we're close to running out of time. If you want, I can do a quick demo of how I do it or like that. So most of the time, or one thing that's actually works well is going crossqa.debian.net, yeah, and yeah, like picking a random package.
The second class is mine.
Second class is yours. Deal. If you look here, it helps. Look in the last column. We have user tag. And sometimes we have a bug reported already or even a patch. So in case of tworld, if we go there, it'll happily tell you here there already is a patch reported, and all you need to do is apply it probably. So that serves kind of as a deduplication method for work. Sometimes the user tag is missing, and then it won't be mirrored here, but much of the time it works. In case the bug doesn't have a patch tag, it says like, yeah, so this is a fails to build from source bug. It's also mirrored here. So if it doesn't build from source natively, don't bother building it cross because it won't work most likely. I just mirror the bugs here. If they're properly FTBFS tagged, they'll show up. So yeah, well, that may be why it looks green first and then becomes red. And then we are into a package. You said deal. So here we can see deal did cross-build at some point and then stopped cross-building. And then we can, so what does it say over here? The first section here is about satisfiability. And okay generally means it's some good thing, means that part is okay. Sometimes we see here something other than SKU, like missing dependency or like that. And in this case, it's a SKU, which means the version of libgcc S1 is different between AMD64 and the architectures listed here. And as long as there is a version difference there, which most likely is the build hasn't caught up and AMD64 was faster in this case. So as long as that's the case, we cannot cross-build for that architecture. That typically is not a problem in testing, because testing moves them in sync, and the release team nowadays ensures that multi-out same libraries are BinMU synced, right? You have automation for that. I've rarely seen issues with that anymore.
Because on our website it says same, so you know that you have to schedule it.
Yeah, sure. That's good. And so we can build it for the other architectures. So let's look into a failure, which is what I'm doing mostly. The cross-build logs on this system are always non-parallel because it's the only artifact saved, and looking at non-parallel logs is a little easier than looking at parallel logs. So scroll to the bottom and see what's the issue. And in this case, the one thing to see is the exec format error over here, which means we tried running something for the host architecture, and then we can't do that, right? And the something is make count table. Okay, let's look into that. So make count table. It uses stdio. Yeah, sounds good. The question to ask here is, does the architecture of the utility matter? Does it use like size of or something where the output is dependent on the architecture we run it as? And our quick look says it's not. So we print something, we print this count table, but it's integers, and the count table is generated over here. It does some bit shifting, and since it's all decimal and like that, so I expect that the output of this tool is the same for all architectures. It generates C source code. Maybe some comment will tell us more. Yeah, probably. Yeah, it probably does something architecture independent. So now I look into where it is being built, probably some makefile. There's here, and we generate make count table.ca where it is being built. I can't seem to find the cursor. Oh, there, the clean target. It has an implicit rule to do it, so I can't find a rule at the moment.
That's the place where it is called, isn't it?
This one?
Yeah.
This one is for running it. I'm looking for the rule to build it.
Oh, okay. Yeah.
Yeah, but it is the failure in running is due to having used the wrong compiler for building it. So the thing we fix here is we change the compiler for from the default compiler, which compiles for the host architecture, to the one that compiles for the build architecture, effectively changing the architecture of the resulting binary, and then we can run it. Thank you for the question. So I think we are already over time. Yes. Maybe we not do it here. So the idea would be to add a rule over here, which invokes cc_for_build, and initializes that somehow, and then makes the packaging insert that variable into the build, and then it'll probably compile. Maybe, maybe not.
So there's no standard variety for that,
In plain makefile builds, the situation is a bit more diverse. If you're using auto tools, there is an autoconf extension macro for that, and the variable is always called cc_for_build. If you're using Meson, there is a native attribute that you set to true, and then it just works. And for CMake, the situation is difficult. Okay, thanks for your time.